Okay, guys, let me share my screen then. Okay, so today, last time I think we finished with the slideshow with, about arrays and lists. So today we have a new slideshow. This is the first time I'm talking about random numbers. I mean, to you. Have I already talked about random numbers to you before?
I think it was on the array. One of the application is that you can insert random
okay.
numbers to it,
Okay.
but it wasn't in there like just online.
Okay. Okay, thank you. But I I I haven't talked about random numbers as they are as in a separate slideshow. Okay.
Yeah,
Okay. So let me do this. Here I have 7 slides about random numbers, and after that we are going to switch to the subsequent slideshow about operators and expressions. But this one will be quite long, so I assume I won't be able to finish it today. Okay, have you already used random numbers in your exercise class? Do you know how to generate them in C#?
I think we used it, yes.
Mm-hmm. And can you recall how you did it?
Like random
Mm-hmm.
R&D and then equals, yeah,
This is it.
random.
Okay,
Like,
great. Okay, great. Yeah, this is the first step. You have to use a special actually type in the .NET framework, random type. Actually, this is a class, a so-called class in the .NET framework. After the autumn break, we are going to learn more about classes. Classes are like compound data types, and one of them is random. This is the name of it. And basically, what you have to do, you have to initialize. You have to declare a variable of this type, and then to initialize an instance of this class. The new keyword is used to generate a new instance of a random number generator. So inside the R&D variable, you basically have a random number generator instance, and this is what you use in your program. Okay, once you have such an instance, I guess you already know that there is a next method inside. Have you used it already? I guess you did. You have. So you can call the next method of this R&D and this random number generator.
yes, we used this one.
Okay. So this gives you the next random number. Actually, it's important that it is an integer, so you can generate integers as random numbers. And I don't know if you knew there are 3 different variations of this next method. I assume you used this one with 2 parameters, didn't you?
yes.
Okay. So I guess you know how it works. You have to specify a range with the minimum and a maximum.
Yeah, and it starts like from 0, but the minus, I don't know if we generate anything in the minus.
You can. If you can plug a negative number into both parameters if you want. Yeah. Because I didn't mention this. It's important that the result is always an int value, so it can be negative as well. Okay, and did you know that the second parameter y is a, oh, come on. So the second parameter here, y, which is 20 here, is a non-inclusive.
It's like -1. It will
Yeah.
be 19.
Exactly. So it's not part of the range. Basically, it's decreased by 1. So in this case, you can generate numbers up to 20 minus 1. So it is 19. Exactly. So you shouldn't forget about this. The lower bound is an inclusive bound, so it's all right, but the upper bound is non-inclusive. I cannot tell you why this is the case. It's a traditional parameterization of this random number generator.
I think because like the one random next 100, so they count the 0.
Yeah, probably.
So it's like 100 number.
Yeah, probably you are right. Exactly. It count 0 is also counted. Yeah.
Like from -20 to 19, there is a 0 in the middle, so they count.
Yeah. In this case, it seems logical. Yeah. Okay. So the situation is very similar if you use only one parameter here. In this case, the lower bound is fixed to 0, and in this case, the same holds what you just mentioned. So we can generate a number out of 100 numbers in this case. So we count 0 as well. Therefore, we count generate a number between 0 and 99. Yeah, good. So y is a non-inclusive bound here as well. And there is also a variant of the next method without any parameters. This is the most interesting one. So in this case, we generate an integer, of course, starting from 0, so it's non-negative. But the question is, what is the upper bound? The upper bound is the
max value?
Yes. It's the int dot max value. The possible largest value for I cannot write like this. Int dot max value. Yeah, this is the highest possible value for an integer. Great. Okay. Okay then. So this is how you can generate integers. There are 3 ways in the .NET framework. Now let's see how can you generate non-integers, floating point numbers, because you can also you might also need this in certain programs. For example, if how to say, let's suppose you will work for a industrial company where you have to run simulations, and in simulators you will probably need to generate floating point numbers in a random way. So for this, in the .NET framework, you can use the nextDouble method inside a random class. This does not have any parameters because the range is fixed. It's between 0 and 1. Yeah, well, it's interesting that you are not even allowed to specify the bounds of the range, but well, this is a fact. You can only use this method for such a purpose. Okay, but of course, and this is something I will ask from you, in general, you will need to generate double values from a arbitrary range. So yeah, so for example, how to say, let me show this to you. So for example, I could ask you to generate double values between, I don't know, 10 and, you know what, 0 and 100. Okay. So how can you do that? Of course, first you would need a random number instance, and then, well, I'm going to use the next double method, but it does not have any parameters, so this is all you can do. Just let's try it. It must give a number between 0 and 1. Okay.
So we can simply multiply it by 100.
Yeah, this is the easiest way. Exactly. So you can
Yeah,
multiply.
thank you.
You can multiply it by 100. Why not? That's it. Yeah, this works. So this will give you several numbers. Oh, you know what? Let me just put this in a loop to generate several such numbers. So let's say I'm going to generate 20 such random numbers, random floating point numbers between 0 and 100. And here they are. We have nice big values like 98 dot something. Okay, so this is the way to do it. Okay, of course I could tell you to generate numbers, I don't know, between 20 and 100. So how to change the code, the source code, to generate numbers which are not less than 20?
Well, I have an idea, but it will be easier to type.
Okay. You want to try it first before sharing your idea?
New random not to be empty from 20, 100.
Thank you.
Again, please.
Yeah, 20, 100.
This is the point. So unfortunately, the next double method does not take any parameter.
No. I mean the random in first initialize.
Up here. Here.
Up, yeah, here, yeah.
No.
It can.
You cannot. Well, you can pass only one parameter. It is called a seed, but it has a completely different purpose. In a minute, I'm going to talk about this one. No, this is not the location where you can specify 20.
I think just like Oleg said, you have to put the min value or max value.
No, it's not the final version.
We can make a big if the number is more than 20 exit.
Yeah. It could also work. Yeah, but there is a nicer solution. Just try to change this code which I highlighted. Ah, nice. Okay, let me. Oleg, you are really in a good shape today. Congratulations. Okay, this is it. So if you want to generate.
I try my best.
Excuse me?
I just try my best.
Okay. Great. So if you have a range like x, y, so you want to generate random double numbers in this range. Of course, the lower bound is an inclusive bound, the upper bound is a non-inclusive bound. Then that is it. You have to subtract the bounds from each other. So now, what does it mean? What should I write here instead of 100?
100 minus 20.
It's 80, yeah?
Yeah.
And then you have to add the lower bound. That's it. So plus 20, right? Yeah, this is it. So first we generate a number between 0 and 80, and then we shift it by 20. Wow, nice. It seems working. Okay, really good, really good. This is the general expression, general algorithm to do this. Really nice. Okay, so actually in my slides I give you another but worse idea. If you want, you can try it. But here comes Oleg's idea. So this is how you can do this. Just look at the one in the bottom. So now I'm trying to generate a number between minus 100 and plus 100. So I got 200 here. Why? Because I subtracted minus 100 from plus 100. So it's 200. Actually, this is the length of the range. And then I subtracted the minimum value. Actually, I added the minimum value. Okay, so I applied Oleg's formula. Actually, we should call it Oleg's formula officially. What do you think?
Well,
Now we're gonna make a petition to change it.
Okay.
Oleg's idea.
Okay, so this is all what you can do with a random number generator. You can generate integers in given ranges. You can generate now doubles in arbitrary ranges. And well, I just realized there is another next method inside the random class which I never used. If you want, you can try it. I think everything is written in the comment, in the help text. Anyway, since yeah, so I what's the English word? I promised to talk about this guy here. So when you instantiate the random number generator, there is an optional parameter here. Here it's called the seed value, and I'm going to talk about this one, but let me show this to you. So if I put some value here, just a random value, I mean I made it up, and I execute the program, try to memorize the first 3 or 4 values. Okay, so it's 96.03 something, 80 and 75. I execute the program again and I get the same values. Every time I execute the program, I get the same values. So what does it mean? It's not random anymore, right? Well, it looks like being random.
Well, random is not
store
even
them.
random anytime.
Store the 10 random numbers.
Okay, I didn't understand anything.
It's like store the same 10 numbers.
Yeah, now
No.
we generate the same numbers, but why, Rashid? Or Oleg?
Well, it has maybe a specific exponent or something like that. So it's a sample.
Mm-hmm. Well, yeah, it has a specific formula which generates these numbers. So actually, the random number generator inside .NET Framework is not really random. It looks like random, but it is not. Let me explain this to you. So we are using computers which are not random. I mean, by by how to say by construction, they are not random. They are deterministic. So it's not really possible to do anything random with our computers, what we use today. And so if we want to do something which looks like random, we have to simulate the random behavior. And this is how it is done in most of the cases. They define a mathematical function which generates numbers in a very, how to say, in such a way that looks random. Actually, this function is called a pseudo-random number generator function. Okay, let me just search for it. Probably we can find some explanation on Wikipedia or somewhere else. Pseudo-random number generator. Okay. Okay, Wikipedia. Pseudo-random number generator. What does this mean?
It means that they are all generated previously. So
yeah, generated deterministically. So actually, there is a given sequence of random numbers, and in this sequence, the numbers are generated one after the other. Of course, you cannot know what is the sequence of those numbers, but the fact is that this is not a truly random behavior. So this is how it goes. There is a sequence of numbers. You start from a value which is called the seed value. You see, this is the seed value here. And when you call the next function, it will give you the next value, next number in this sequence. This is why we call the method next. Of course, if you specify what the seed value should be, the sequence starts always at that point. So you get the same numbers again and again and again. This is why I generated the same numbers with my program. Okay.
how many seeds do we have?
You can
Infinite, I think.
Well,
so it's int. It's not
int,
an
yeah.
infinite amount. Yeah,
Int.
but it is from the minimum value, so from the negative value of int. Yeah.
Let's try it. I don't know. Let's try to use a negative value as a seed value. It should work actually. Yeah, it works.
Oh, okay.
So you can go to the int min value if you want, I guess. Okay, till the max value if you want. Doesn't really matter. It should be in the range of integers. You can take any value. It doesn't really matter. I mean, what does matter is that you get the same sequence of numbers in this case.
Okay.
And this is something which you need sometimes. I just mentioned the use case. You have to implement a simulator at a company, and it's really cool if you can rerun the same simulation. So you can generate the same sequence of random numbers again and again. And you can start a new simulation by changing the seed value, right? So this is something what is commonly used in real life. Okay. So, of course, as you already know, you are not forced to give a seed value. Let's see what happens in this case. You already know, in this case, you get different numbers. Now, so now we have numbers like 69, 37, and so on. If I rerun the program, I will get different numbers. So now it looks really random, although it isn't, but it partly is actually. So if you not specify a seed value at the initialization of your random instance, then the system generates a seed value for you from your computer's clock. So it looks at your computer clock, what the time it is, and from this seed value is generated. And this is more or less random. I mean, partly random, right? It is not random, actually, deterministic, but you are the random element in this equation. You push the F5 button, and when you push it, well, it's kind of random.
So if I will push it in 2 different days on the same time, the values will be the same.
I don't think so.
No?
I think they will be different. So the date also matters.
No, date also matters.
I think time is measured in computers. So they measure how many seconds or milliseconds. I'm not sure how many seconds already passed. Starting from 1970, January 1, something like that. But I'm not sure. Let's see. Computer clock. I don't know.
Speed measures, I think, the one.
No, not this is what I wanted. The how time is measured in computers. Let's see. I have no clue. I'm not really sure. Anyway, I hope you understand what everything what it has to do with the random number generator, random number generation. Or do you have any question regarding the slides?
No.
Okay. I want to mention something else. So maybe in .NET you can only use this pseudo-random generator. You might need to use real real random numbers. So I just want to show you a web page. A web page which is about generating real random numbers. Actually, this web page provides a web service you can use from your programs if you want, as far as I know.
I'm not sure, but I heard that they calculate the numbers regarding to the weaver.
Regarding what?
They calculate random numbers on the value of weaver in some regions.
River, I mean.
Weaver, well, rains or.
Okay, yeah.
Pressure. So,
yeah, something like that. I guess they use. They measure some natural phenomena like rains and sunshine or rivers. So they assume nature is random, at least, and based on this, they generate random numbers. At this web page, actually, I think it's written here somewhere. They use something like, oh come on, where is it? here it is. They measure the atmospheric noise, so it's similar to what you just said. They use sensors and measure this noise, and out of this noise a truly random number is generated. So now this number is truly random if we believe what is written here. Okay, this was just something interesting I wanted to show you. Okay guys, let's switch to the next slideshow about operators. Let's at least start to read it. Okay, so this is a topic what you know something about. I'm pretty sure you know something about because you already use operators a lot. So by operators I mean operators like multiplication or addition, or this is also an operator actually, the operator of assignment. You already learned how to compare two numbers, for example, by using the less than operator. And yeah, you learned so many operators and use so many operators already. In this slideshow, I give a comprehensive overview of operators because there are certain details and technical details and depth which you don't talk about in the exercise class. So here it is. We are going to learn about the depth of operators and expressions. By expression, we mean something like this. So this is an expression using, for example, variables or constants or literals as fundamental building blocks, which are then connected by operators like this operator of multiplication. Okay, so there are so many operators in C#, not only in C#, in every programming language. And typically the huge number of operators are divided into these three classes. So there are unary operators. By unary, we mean that the operator has only one operand. There are binary operators where the operator has two operands. For example, multiplication is a binary operator because it has always a left-hand side operand and the right-hand side operand. So it's a binary operand. And interestingly, there is also a ternary operator in C#, but not only in C#, also in Java or JavaScript or Python, or in most of the languages, there is at least one ternary operator. Okay, so let's start with unary operators. I'm pretty sure you can tell me some unary operator you already used in C#. Operator only with only one operand. So what do you think? Have you already used such an operator?
Maybe the addition to I plus plus.
Plus plus.
Yeah.
Plus plus is a unary operator. Exactly. It has only one operand, right? X plus plus, for example. X is the operand. Yeah. Anything else?
Minus minus.
Minus minus. Yeah. Okay. Great. So here you can find plus plus and minus minus as unary operators. Okay, there are other trivial operators which you probably know about, but yeah.
Oh yeah.
One typically forgets about them. You can use the negative sign and also the positive sign. They are also unary operators. And yeah, I'm a little bit disappointed that you did not mention the negation operator. you know, this logical operator. It has also one operand. You know how it works. It takes a bool value, true or false, and flips it. Okay, I just want to mention that there is a bitwise variant of the negation operator, which, well, as you can see here in the example, flips the bits inside your variables. It turns ones to zeros and zeros to ones. It's not really common to use this operator. Actually, I already did a few times in my life, but it's really not that common. But let me show you how it works. It's not that difficult to demonstrate it. So let's suppose we have an integer value in this variable, and I want to, let me just put it on the screen, and then I'm going to negate it by using this bitwise negation. You can bitwise negate any numbers, I mean integers, short values, long values, floats, doubles, whatever. And let's see what we get.
It will be okay.
Yeah, it will be almost the same number in the negative range, -1, something like that. It's interesting. You can ask why we would need this, but I show also that actually what happened is exactly that bits were negated. So I just looked it up before the lecture in Stack Overflow, how I can convert a number into bits, I mean a binary number, and this is what I found. I think you already know the convert class. I think I remember that you already mentioned this to me, and it has methods starting with 2, so you can convert something to a given type. Now I'm trying to convert my number into a string of zeros and ones. And well, this string convert the string method has so many variants. It has 36 different parameterizations. We need something with int. Maybe this one, but with another parameter. Where is it? This is it. So you can specify the int value you want to convert and also the base. I mean, if you want to convert it to a binary number, then the base is 2. If you want to convert it to a hexadecimal number, then the base is 16. As you can see, the base can be 2, 8, 10, and 16 only. Okay, I think this is it. So let's see. Okay, so here you can see the number 354 in binary as a binary number. And let me do the same with the negated x. Well, yeah, the problem is, it worked, but the second one is longer because
it has ones instead of zeros.
Exactly.
And zeros are not typed.
Yes, exactly. So here, for the first binary number, we cannot see the zeros at the beginning, the leading zeros. I also looked it up in Stack Overflow how to display the leading zeros, and there is such a method here, pad left. You can pad, so add padding to your string. You can put a certain number of characters on the left hand side or the right hand side. Now I want to fill the string with zeros until the string will be 32 character long, something like that. So this is how you can put the leading zeros to the left at the beginning, up to a certain length, which is 32 now, because int has 32 bits. Okay, long story short, here are the binary numbers with leading zeros, and now you can see that negation worked. Okay.
Yeah, but we don't have to use the second pad left because it's filled with ones.
Yeah, now we don't have to. Of course, if you have a huge number here, maybe it's too huge. Yeah, it is. Okay. Then we might need it.
No.
Okay. No, not now. Yeah, I know. So, for example, if x is negative, then it starts with 1. I think.
Oh, yeah. Then
Yeah, now you would need the leading zeros for the second number. Yeah, thank you very much. As far as I know, you learn about how to represent numbers in binary format. You have another course about it, right?
Yes.
Yes.
Yeah. Okay. So yeah, you can connect this stuff in C# with this other course of yours. Okay, guys, let's continue. There is another unary operator which you already know. It's called casting or type conversion, when you want to force an expression to take a given type. So you can put the type between parentheses in front of your expression. And this is also a unary operator because you have only one operand x. Okay, actually, I think that's all in C#. These are all the unary operators. So let's switch to, oh, no. Yeah. So I wanted to ask you if any of you know what's the difference between x++ and ++x, because we can use this, we can use both formats, and actually they do the same. They increment x by 1. But there must be some difference between putting ++ in front or after x. Does any of you know what could the difference be?
First, it will display x, then increment it, and the second one will increment it, then display it.
Okay, we can try this. So let's
It's like the difference between plus equal and equal plus.
Okay, let's try it. You know what? Here, let's display x++. So you can ask what we will see, 10 or 11.
This one, it will be 11. No. 9.
Oh,
10.
it's 10. Yeah, because I think this is what you meant. First we display x,
display then increase it,
and then we increase it. Yeah. So this is what the order means. What we do first, we first display x, and only after that we increase x.
Increment.
Of course.
And if we displayed x after it, it will be 11. X just x.
Yes, exactly. Yeah. So it has been incremented, but after being displayed at the first place. Okay, if you do it in the other way around, ++x, then you will see 11 both times. Yeah, so this is the difference. You can ask why this is important. Well, it can become important, become handy when x plus plus or plus plus x is part of a larger expression, like here on the slide. So now, in the first time, we multiply x by 3, and only after that we increment it, and this gives a completely different result compared to the other use case. Okay, that's it. Of course, the same holds for minus minus. Any question about this, guys? Nope.
No.
Okay, then let's continue with other binary operators, because there is a bunch of binary operators, not only in C# but in any programming languages. Binary operators, they have binary operators in the largest number. So of course you already know the so-called arithmetic operators: addition, subtraction, multiplication, and so on. So let me just not comment this. Yeah. Okay, when you use those arithmetic operators, there is a topic we have to talk about, which has something to do with types. So, of course, you must really know what the type of the result will be. Let's check out this expression here. So we use multiplications twice. So the type of 2 is actually an int. This is an integer. R is an integer. Pi is a double. So the question is, what is the type of the result? Now it's easy to see that it must be double, because the result typically is a floating point value, right?
Yes.
Okay, so sometimes it's easy to find out what type should be written here, what the type of the result should be, but sometimes it's not so straightforward. There is a golden rule, however. This is it. So the result is converted towards the larger type almost always. So now the larger type is double. Yeah. So let me just do let me just test this idea. So for example, if I have an integer and I have a long value, so my question is what the type of the result should be. For example, if I multiply those two, so what do you think? What should I write here?
Long.
Yes, exactly. Long is the larger type, right? Does this
Yes.
work? Yes, it works, actually. Actually, if you are not really sure, Visual Studio can help you. For example, now I accidentally picked int and I get an error message. Of course, I can check out the error message, and it says that, well, you have a long expression. This is of long type, which you would try to convert to integer. So it's not okay. It also shows at the at the top of this text box that the operator multiplication returns a long value. You can see it in front, long. So it's so obvious to use long in this case. Yeah, so let's try something else. Like, what if I have a floating point number here? So what do you think? What should I write here? What is the what?
Float.
Yeah, float. Why?
Larger.
Why?
Because float is larger.
In what sense? We learned that both types are represented on 4 bytes. So both are 4-byte types. So float is not larger in this sense.
Maybe it's the value of the float.
Yeah. So yes, the value of the float is in a larger range because it can represent not only integers but decimal numbers as well. So in this case, in this sense, it's larger. Yeah. This is why I've put the larger word in quotation marks. So yeah, in this sense, float is larger. But there are also some interesting phenomena. If, for example, I try to use a really large integer here, long is larger because it takes 8 bytes, while float takes 4 bytes, and still the result is float. So this golden rule does not cover everything, and the fact is that there are several rules. I checked out all the rules on the Microsoft web page, and I tried to sum them up here in 5 points. So those rules more or less cover all the cases. So this is something you should know, not only in the exam but in real life, because if you don't know what rules to apply, then you can just, how to say, be surprised what is going on sometimes. Let me show you an example. So for example, let's suppose I have a byte value here and another byte value there. And yeah, so what do you think? What type should I use for the result? It seems so obvious, isn't it?
Yeah, we have only one type, it's byte.
Byte, yeah, of course. And the C# compiler does not allow me to use the byte type here. Why? I have everything, every data here is byte. Why shouldn't I use byte here? It tries to convince me that I should use int. Why? Okay, of course.
Because the value is large for byte.
Yes.
Well, in this case, it's not, because the value is 20. I multiplied the two values, so it would fit inside the byte. Of course, if I have larger values like this, then yeah, then you are right. So it wouldn't fit inside a byte. But yeah, but if I use integers here with really large values, I'm pretty sure that the product of x and y would not fit inside an integer. It's still okay. So it's kind of interesting, and yeah. So let's see what's going on behind the scenes. So these are the 5 rules we learn about. Let's see the first rule. So if the 2 operands are of the same type, then the result is of this type. This is a golden rule, but not always true. Just remember when we use 2 bytes. So it's not always true, because there is the second rule which says that the result should be of at least a 4-byte type. This was the problem here. Byte is a 1-byte type. The result should be at least a 4-byte type, such as integer or uint. it does not matter in this. Maybe it matters. Okay, then let's use integer. So this second rule has some technical has a technical explanation. It has something to do with the processor architecture you are using. Anyway, just remember it. Okay, the third rule seems also obvious. We already know this. If one of the operands is a real number, I mean the floating point number, then the result should also be a floating point number. We already experienced this, for example, when I used a long here, a float there, then the result will be of the floating point type. So this is implied by the third rule. Okay, then we have two other rules which extend the first three ones. If we have like two floating point types here, which one do we take as the type of the result? Float or double?
The biggest one, double.
The biggest one, exactly. The biggest one, the larger one, so it must be double. Exactly, and the same holds if, for example, I have two integer types like int and long, then the result takes the larger type, of course. So this is so logical, right? And let me talk about the final rule here, which is a little bit lengthy. And actually, this is the most specific rule among the five rules. So what does it say? So it says if the two operands have the same size, but one of them is signed, the other one is unsigned. Okay, so we have signed and unsigned types. So this rule is only about integer types, and it says they have the same size. So for example, if I have an integer here and a u in there, this is the case what this rule is about. Two types of the same time, one of them is signed, the other one is unsigned, and in this case,
in this case we choose int.
Yeah. We choose what? Int?
Int.
Yeah, this seems logical, right? Because because we can have a negative number here, for example, so the result can be negative. So we really need a sign type, right?
Yeah.
Well. Yeah, I agree with you, but the fifth rule tells us something else, and this is it. The result will be long.
Oh, okay.
Okay. Why not? Yeah, so this is written here. Then the result is signed, so you were right, partly. But the type will be a larger type, larger than int, larger than uint. And what is larger than int? It's long. Okay. This is it. This is the most interesting rule in the .NET framework regarding types. Yeah, it has one explanation which I want to share with you. Like if I take very large numbers here, so you know that. Okay, anyway, let's take a large number, and another large number here, which can fit only to a uint. So if I would use int here, then this number cannot be used here. It's more than 3 billion, which does not fit inside an integer, but it does inside a uint. And now if I multiply or even add those two numbers, the result would be larger. It wouldn't, I'm not sure it would fit inside a uint. It wouldn't fit inside the int, but inside the uint, yeah, and probably not inside the uint. So we have to take a larger type. But you know what? Let's try this. Let's try to convert it, cast it to integer, and let's see what do we get. Okay, so you see, it's kind of suspicious because I added two positive numbers and I got a negative result. So what happened here is actually overflow. I think I already explained what overflow is to you, also in logic and also here in high-level programming languages 1. So basically, we reach the maximum value of an integer and we just overflew to the negative range. And this is what happens here. This is an obvious error in this program. And the C# compiler tries to avoid it by switching to a larger type. So now in this case, everything seems to be normal because the result can fit inside a long type. Do you have any question?
What is the meaning of the second underlined red line? X is integer, Y is real, then result is real.
What is the meaning? Real means floating point number.
No. Okay.
Yeah, I should change this word to floating point. Float or double. It's so difficult to write like this. Anyway.
Yeah, for the decimal numbers to fit in.
Yes, exactly. Okay, I have a few exercises for you. So let's see if you understand what those rules are about. So please tell me what types to use. Let's start with this one. This one, okay. So what to write here?
Int.
Byte. Oh.
It's int.
And because it has to be at least 4 bits.
That's it. That's it. The second rule, right?
Yeah.
The result should be at least 4-byte type. Neither byte nor short are 4-byte types. The byte is a 1-byte type, short is a 2-byte type. So you are perfectly right. Great. So let's do the second one. What to write here?
Int again.
Yeah, it's int. Yeah, this was easier actually. Okay, third one.
Long.
Yeah, that's easy. How about this one?
uint.
No. Yeah. No, you.
It is. Why? Do you have any doubts?
The value is not too big.
What is the value in this case?
It's in the minus.
It's positive always.
It's -2.
Yeah, it's -2.
Yeah.
And but the C# compiler uses an unsigned type uint, which is not able to represent a negative number. Okay, let's try this one out. So if you have a byte here, and what was the other one? Uint.
Uint, yeah.
And we subtract them from each other, and in this case the type is uint for sure. I can show it to you. There it is. This is what the C# compiler tells me. The result is generated as a uint value. Then this is the value what we get. It's more than 4 billion although it should be -2. So what happened here?
Overflow again.
Overflow again. Exactly, overflow. So although we have these nice rules inside the .NET framework, sometimes you are the one who has to think a bit, and you are the one who knows what values we can expect in X and Y. And if you are not sure if this uint will be okay for you, then you should do some tricks like
using long.
Yeah, you can use long, or I mean, what do you mean? Where should I use long?
At the result.
Here?
Yeah. Because it may overflow the uint. Actually, well, if we
did not work.
Seriously?
I mean, it does not work because the problem is that here the right hand side is generated as a uint number.
Oh.
So we can try ulong? I don't know.
Ulong.
No. It will doesn't affect. We need to do something with the entrance. Well,
Yeah.
with the X and the Y.
Exactly. So for
But I don't know what.
If you pick int here, then the result will be generated as an int, as a signed number. Exactly. So you have to be clever here when you choose the original types for your operands. And in this case, there will be no problem. So this will be -2. So this is your responsibility. Not even those rules can avoid some problems with your data, because they are your data, but sometimes they help to avoid the most common problems. Okay, thanks for noticing this. This was something we learned additionally. Can we go on to the next one?
Think the same problem here?
Yes, probably. Yeah, definitely. We would get the same problem. Exactly. So here again, let's try it. Yeah, let's try it. It doesn't take too long. Too long. So it seems working. The C# compiler let me do the stuff, but when I run the program, it's miserable. It's almost the maximum value for a ulong. So it's a really huge number instead of -2. So what should I do then? I can
change them to long.
Yeah, it seems to be sufficient to use only one of them to long, and it does not work. Somehow it does not work. It does not even compile. I mean, I cannot even execute my program because I have a
because we have to use something more than long.
Yes.
But we don't have. Do we have something more than long?
No.
No.
I mean,
no.
There is one. Yeah, I will. Just a minute. But this is the point. Yeah, the last rule, the fifth rule, applies now. You have two operands of the same size. One of them is signed, the other one is unsigned. And the result should be of a larger type, and there is nothing larger than long, I mean, as an integer type. Exactly. So here the C# compiler just doesn't know what to do. It doesn't have a larger type, and you cannot execute this. Of course, if you change the other ulong to long, everything will be perfect, but yeah. And yeah, so this happens here in the fifth example. Yeah, we have some interesting type in the .NET framework. There is an additional type I actually have not used. I mean, I cannot recall if I used it ever.
There is a longer data type called long.
No, not in C#. It's not that
no.
it's not that ridiculous, because in C++ you have a
Yeah.
long type,
Yeah, there is.
but in C# you don't. On the other hand, there is a type which is called decimal, but I'm not sure. I'm not really sure what it does. to be honest. Okay, it's for a floating point number. Okay, then it does not help actually. Okay, then there is no larger integer type than long in C#. If you really want to do calculations with arbitrarily large numbers, then just use Python. We learned that the programming language Python can deal with integers of arbitrary sizes. Okay, last exercise here. What should I write in front?
Double.
Double, yeah, okay. This is the larger type. Okay, can I continue, or do you have any question?
Oh, you can, yeah.
Okay,
I think so.
I can. Okay, but let me emphasize that this will be an important part of the exam if you have to talk about this topic. I mean, the topic of operators. So this is important. You should be aware of those rules. Okay, guys, let's continue. We have further binary operators. Oh, it's almost end of the lecture. Okay, let me skip this one. This is not that important. Next time I will talk about it. But let me just talk about the ones you already know. You already know these guys. These are the so-called relational operators. You can compare two pieces of data. Okay, let me just not talk about it more. Okay, one more sentence. So as you know, here x and y can of any data type. The result here is always of what type? What is the result here? It's true or false. What's the type which can take a true false value?
Bool or
Yeah.
boolean.
Yeah, it's bool. The result is always bool here. It's not a question.
Yeah.
Okay. Once you have bool values, of course, you can use the logical operators, which you already know. You already know the logical AND and logical OR. Here, x and y, both x and y must be of type bool. Probably you didn't know, or maybe you did, that there is a bitwise version of the AND and the OR operator, which is applied to the bits. pairwise. Next time I will show you some demo in Visual Studio how they work. Let me just skip this now because I want to talk about one of the most important group of binary operators, which are the assignment operators. Of course, you know the basic assignment operator, the simple the equation mark. But this is not the only assignment operator. Have you ever used x plus equal before? Yes. You did?
In
okay.
Exercise.
In the exercise, that's great. So you know what it does? It just increments x by y. Did you know that you can do the same with the other arithmetic operators as well? Have you ever used minus equal, for example?
No.
No. Just give it a try. For example, try this. For example, you can easily multiply x by y. But you can also do this with the remainder operator. Crazy. Okay, and it gets even crazier. You can combine the assignment operator with the bitwise operators, like the bitwise and or and the shifts, which I'm going to talk about next time. Yeah, and I think that's it. Now I stop. Next time I also will talk about string operators, character operators. I'm going to talk about the ternary operator, and then the precedence table of operators, because every programming language has a precedence table for operators. And finally, you will have some exercises. Maybe you can try to solve those exercises if you have any free time in your autumn break. Yeah, so that's it. Some final questions at the end, guys? No. Okay, so thanks for your comments meanwhile during the lecture, and have a very nice autumn break next week. See you in 2 weeks.
You too.
Bye-bye.
Bye.